For the second of your 2 retreat lessons, we're going to talk about adding and subtracting these things. 2 points. Number 1, you must state your least common denominator. And number 2, you must factor. These are 2 non-negotiables, and you'll see why. We're going to go ahead and just do some examples of this. Number 1, if I take 3x squared minus 8 over x plus 2, and I subtract x squared minus 9 over x plus 2, and I want to state my LCD, I already have it. My LCD is x plus 2. So what I'm going to kind of do is just do a little exercise of putting these things in parentheses and seeing how this all works. So whenever we added fractions before that had the common denominators, we knew that we could just add the numerators. Well, we have to deal with this negative symbol that's out in front of this first fraction. So what my teachers always taught me was just kind of carry it through and distribute. So what I'm going to do is 2 steps. Number 1, I'm just going to draw one fraction bar with an x plus 2 in the denominator. And number 2, I'm going to just put the numerator down, but I'm going to distribute the negative, minus x squared plus 9. Then we're going to simplify, adding like terms in the numerator. So I have 2x squared plus 1 over x plus 2. See if you can factor. You can't, so we're done with that one. Number 2. Number 2 is going to be, let's do 1 over 6a squared plus 1 over 3b squared minus 2 over ab. And my least common denominator, when I add these, let's look at the constants. I have the 6, the 3, and the 1. That has to be a 6. Look at a squared, b squared, and ab. I need an a squared, and I need a b squared. So in a very simple form, what I have to do is look at what do I have to multiply the first one by to get 6a squared b squared. To multiply by b squared over b squared. The second one I have to multiply by 2a squared over 2a squared. And the third one I'd have to multiply by 6ab. So instead of writing 3 fractions, I'm just going to write one fraction with one denominator of 6a squared b squared, but I'm going to change all the numerators. The first one would be the b squared, the second one would be the 2a squared, and the third one would be the negative 2 times the 6ab. Then once again I'm going to simplify that numerator, so I get b squared plus 2a squared minus 12ab over 6a squared b squared. You may look at that and say, well, can this numerator factor? It doesn't matter. Even if it could, it would factor into 2 binomials, and that's not going to cancel with the denominator. So just leave it. Third one, got 2 over y squared plus 1 plus 5 over y. And my least common denominator needs to include one of each of these. Well, I have a y, and I have a y squared plus 1. And those could never be the same thing, so that's not going to work. It's like trying to combine. I just need them separately. So once again, I'm going to draw one fraction bar with the LCD on the bottom. Then say, what would I have to multiply this by to get the LCD? I'd have to multiply it by a y. So I'm going to have 2y on the top. And then on the 5, in order to multiply this to get the LCD, I'd have to multiply it by y squared plus 1. So the 5 is going to get multiplied by a y squared plus 1. Then don't cancel things. We have to simplify and see if we could refactor it. If I simplify, I'm going to get 2y plus 5y squared plus 5 over y times y squared plus 1. And there's no way that that could ever factor to become a y squared plus 1, so that one is done. Number 4. Here's an example of ones that we might have seen before. 2c to the negative 1d plus 2c d to the negative 1. Well, if I treat each of these like their own fractions, I'm going to actually create a situation where that moves down and that moves down. So I'm going to have 2d over c plus 2c over d. And my LCD is going to be CD. The first one's going to get multiplied by d over d to give me 2d squared The second one's going to give me plus 2c squared multiplied by c over c all over cd. Now, that could be simplified, or I could factor a 2 out and leave it as 2c squared plus d squared over cd. I'd probably leave it like that because it looks cleaner, but this is certainly fine too. For number 5, I have a over b minus a plus b over a minus b. You may think that my LCD would be b minus a times a minus b, but that's too complicated because I can actually rewrite this entire thing with these two denominators being exactly the same thing. A minus b and b minus a are opposites, which means I can change that first fraction to have a negative numerator, negative a over a minus b, and add b over a minus b, and just state that my LCD is still just the same a minus b. So when I add them, I get b minus a over a minus b. Once again, b minus a and a minus b are opposites, and they're going to cancel or divide by each other to give you a negative 1. Okay, last problem. We're going to do a plus b over a minus b plus a minus b over a plus b minus b minus a over a minus b plus b minus a over a plus b. Before I worry about an LCD, let's see if we can start adding some like terms here, or some terms, sorry, not like terms, terms with the same denominator. These two I'm boxing in here already have a common denominator, and these two that I'm boxing in also already have a common denominator. So if I group those together, the first set, the one in blue, I'm going to do those in blue, I'm going to get a plus b, distribute the negative, minus b plus a all over a minus b. Then for the second set, I'm going to get a minus b plus b minus a over a plus b. Okay, let's combine like terms in the first one. The b minus b is going to cancel, and I'm going to get 2a over a minus b. And for the second one, I'm going to get actually 0 over a plus b, which is just 0. So my final simplified result is 2a over a minus b.